Hi, we're going to do some gas stoichiometry practice. This sometimes can be challenging for students, so I thought we'd do two more examples with you. So remember, gas stoichiometry, we are going to identify that they give us all the information with pressure, volume, temperature of one substance, but they want the answer for a second substance. That's what clues us in that we're going to use the ideal gas law and stoichiometry, the molar ratio, to walk the bridge. I'm going to do two problems. Let's first do this number 95 together. Let me read it to you. Lots of words, lots of numbers. It says, if 1 liter of hydrogen gas measured at a temperature of 20 degrees C and a pressure of 80.1 kilopascals is burned in excess oxygen to form water, what mass of oxygen? Okay, huge clue here. They give us all of this pressure, volume, temperature information for hydrogen, but the question is, what mass of oxygen? So information on hydrogen, want the answer for oxygen. Right away I go stoichiometry. To go from one compound to another, we have to do stoichiometry. It says assume the temperature and pressure remain constant. So I see all this pressure, temperature, volume for one substance, and we've got to get to another substance. I'm going to have to use Pivnert, the ideal gas law, because it involves amount of substance, moles and mass, and we're going to walk the bridge to get to the oxygen. Okay, so to begin, I'm going to go ahead and write all of this down, all the information that they gave us. Here it is. It's a hydrogen and oxygen producing water reaction, quintessential reaction. And here's the information that they gave us. They said that the volume was 5 liters for the hydrogen, Let's see, 5 liters. The temperature was 20 degrees C. So I'm going to pause right there and go ahead and write this as Kelvin. We always have to have Kelvin for gases. 273.15 gives us 293.15 Kelvin. And the pressure, kind of interesting, was given in kilopascals. It is 80.1 kilopascals. Now, because I'm going to use the ideal gas law, I have to have pressure in ATM. Let's go ahead and convert that. There's 101.325 kilopascals for every 1 ATM. Notice kilopascals cancels out. ATM is what we want, and that gives us 0.791 ATM. Now the question is, how many, it was how many grams of oxygen. It wants to know mass, the grams of the oxygen. So writing all of this out, writing what they've given us, I see the information for hydrogen, but they want oxygen. So we're going to have to walk the bridge to oxygen, and the only way we can do that is to have moles of hydrogen. So I'm going to use this information with the ideal gas law, PV equals nRT, to find those moles. All right, R, we always have that, 0.0821 ATM times liter divided by mole times Kelvin. Okay, let's go ahead and solve for our moles. I'll divide both sides by RT. We get N equals PV over RT. We'll go ahead and plug in. Moles is going to be 0.791 ATM, that's your pressure, times the volume is 5.0 liters, divided by the gas constant, 0.0821 ATM times liter, divided by mole times Kelvin, always include those units, times the temperature was 293.15 Kelvin. Okay, let's check our units, make sure that we did this correctly. ATM cancels, liter cancels, Kelvin cancels, and there we have it, moles. So when we do this math, be really careful, use parentheses on the denominator. The moles of hydrogen is 0.164 moles of H2. Okay, so we found the amount of substance. Using the ideal gas law, we found the moles of hydrogen, but they want the mass of oxygen. So to go from one compound to another one, we walk that bridge, the molar ratio. I want to get rid of, remember I always do my units first, moles of hydrogen and end with moles of oxygen. Then we just look at our molar coefficients. 2 moles of hydrogen are going to react with 1 mole of oxygen. So 2 moles hydrogen react with 1 mole of oxygen. Now we can bring this to grams, simply using molar mass. I have 2 oxygens, so 1 mole of oxygen gas is 32 grams of oxygen. Go ahead and put all of those numbers into our calculator, and we are going to get a mass of 2.6 grams of oxygen, and there is our answer. Nice. So really it boils down to 2 steps. It's using the ideal gas law to find moles of one substance and then walk that bridge to find the amount of the second substance. Let's do another example. And I'm sure by the time we finish this next example, you will be ready for your homework and you're going to do great on your test. So here's another problem. We are going to do problem 88. Oh, sorry, let me find 88. Let's see. I don't know why I'm not seeing problem 88, so sorry. Did you see that? We are skipping numbers. Well, I'm going to read it to you. I'm sorry. Let me read problem 88 to you. I'm going to try this one more time. Oh, sorry, I don't know why it's not showing problem 88 on there. That's okay, I'll read it to you. Sorry about that. Okay, 88. It says that we have 3 liters of propane gas is completely combusted to form water vapor and carbon dioxide. Let's go ahead and write the reaction for this. So it's a combustion reaction, really good review. Propane means we have 3 carbons. Is meth, eth, prop, bute, pent. So 3 carbons, and they're all going to be single bonded, the ane. That means that we have 8 hydrogens. So C3H8. If you needed to look that up, look it up. Combustion, so combusted in oxygen, that's what combustion means, we burn it in oxygen. And when you have a hydrocarbon combusted in oxygen, it always produces CO2 and H2O. And the problem had told us that these are all going to be gases. I'm going to go ahead and write as I read the information. It said 3 liters of propane. So volume is 3 liters. Is combusted to form water and carbon dioxide at 325 degrees C. Temperature, 350 degrees C. Now, Celsius, got to convert that to Kelvin, so plus 273.15 is going to give us 623.15 Kelvin. Next, it gives us the pressure. Oh, and nice, this pressure is given in ATM, so you don't have to convert it. The pressure is 0.990 ATM. And here's what it asks. It says, what mass of water vapor results? So we want grams of water. Okay, reading that through, first thing that grabs me is we have all this information about propane, one compound, but they want the answer for a different compound. The only way you can walk from one compound to another one is stoichiometry. It's going to be the molar ratio. Second thing that catches my eye, they give me all this pressure, volume, temperature information about propane, but in order to do stoichiometry, we have to have moles. Moles, amount of substance. The formula that we have to use with pressure, volume, temperature to relate amount of substance is the ideal gas law. Right there, PV equals nRT, the N for moles. So 2 steps. We are going to use all this information to find moles and then simply walk the bridge using stoichiometry to get to water. So let's go ahead and do it. Solve for N, divide both sides by RT. And I bet money, I'm hopeful that as I'm doing this, you're already preemptively working ahead of me. Let's go ahead and plug everything in. So moles is going to equal 0.990 ATM times 3 liters divided by, let's write down R. We always have R. I mentioned it in another video. If you're ever like, God, what do I know in life? Say, I do know something. I know R. The gas constant is 0.0821 ATM times liter divided by mole times Kelvin. Okay, let's put that in. ATM mole times Kelvin. There we go. Temperature is, wow, hot. 623.15 Kelvin. Okay, plug all of that in. And the moles are 0.058 moles of the propane gas. Okay, so we use the ideal gas law to find the moles of this gas that's going to react. It says we have excess oxygen, so plenty of oxygen. How many grams of water? Okay, so we're going to walk the bridge from the propane to the water. Okay, little reminder. I need molar ratios. We didn't balance this yet. Let's try and balance the reaction. 3 carbon, 3 carbon. I've got 8 hydrogen. So 4 times 2 is 8 hydrogen. Now let's check oxygen. 3 times 2 is 6, 4 times 1 is 4, 6 plus 4 is 10. I'll put a 5 right there. 5 times 2 is 10. All right, now we're balanced. So as a little reminder, if you're given a word equation where you have to write the chemical equation, remember you have to balance it in order to do stoichiometry. So we are going to cancel the moles of the propane, and we want the moles of the water. That's walking the bridge. Now I look at the ratio. 1 mole of propane produces 4 moles of water. 1 mole of propane produces 4 moles of water. I just write down those molar coefficients. And then they wanted mass. Notice moles of propane cancel. If I stopped right there, you'd have moles of water, but we want grams. So 1 mole of water, notice I put that in the denominator so it cancels, is going to be 18.02 grams of water. So put this in your calculator, 0.058 times 4 times 18.02, whatever's in the numerator we multiply, the denominator we divide. Ones we don't have to worry about, they don't change it. And we get 4.18 grams of water. Beautiful. Okay, nice. I hope that you're feeling more confident. These are very doable. You write down what you're given and ask yourself, do they want a different compound for the answer? You're stuck doing stoichiometry. If they give you pressure, volume, temperature, hooray, you get to use the ideal gas law. Good luck with your work. You're doing good. Keep pushing. Thanks.